Chapter 9, review number 10. In this problem, we are going to graph the velocity function given by v of t equals 3t plus 1. So this is a linear function, whereas many of our other functions have been horizontal. And so this is going to create a trapezoid, and this is over the interval from 0 to 4. And for part A, we want to find the integral from 0 to 4. Remember that the integral is the area under the curve. Okay, so let's start by graphing this. So on our x-axis, we're going to count by ones. Okay, and on the y-axis, we need to get up to probably 4 times 3 is 12. So at least, let's go up to 15. All right. 5. And it would be a little nicer if my intervals were a little bit more consistent, but just a rough sketch. All right, so we're graphing the line. Y equals mx plus b, so I'm starting at 1, and my slope is up 3 and over 1. And so we've got a pretty steep line here, up 3 over 1. And we're doing this over 4 intervals. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, so not quite drawn to scale, but let's drop that perpendicular there. We are looking for the area under this curve. And I know that this point right here is actually at 13, because 4 times 3 is 12 plus 1 is 13. Okay, so this is my trapezoid that we're going to find the area of. How do you find the area of a trapezoid? Area equals 1/2 the height times the sum of the bases. All right, so I'm actually doing part A right up here. So we're looking for the area, the height, as we said, and be careful here. Our trapezoid, let me outline it for you. Our trapezoid, my base, 2 bases have to be parallel. So these are the 2 bases. Base 1 has a length of 1. Base 2 has a length of 13. So the height is 4 units. Okay, so plugging everything into my equation, we're going to have 1/2 of 4 times 1 plus 13. 1 plus 13 is 14. Half of 4 is 2. 2 times 14 is 28. Okay, so 28 feet is the area under the curve. That's our integral from 0 to 4. Okay, let's take a look at what part B is asking us. Part B says, let C be any point N. I'm pretty sure that's not supposed to be there because that does not make sense. Let C be any point on the x-axis between 0 and 4. And we're going to write a general expression for the area under the curve from 0 to C. Okay, so let's get another picture. And so we're looking at any point. We're not going over to 4 this time. We're looking at any point. So let's just call this 0 to C, just calling it some point C. And let's just give ourselves a quick sketch of a trapezoid. Well, what do I know? Okay, again, we're looking at this trapezoid, so I know that my distance on my y-axis is 1. Before I had 4, and how did I find that? So base 1 is still 1. How did I find base 2? I plugged in 4 to my expression. Remember, our v of t is equal to 3t plus 1. Well, now I don't know what my value is. It's not 4. It's just c. So I know that this expression is going to be 3c plus 1. So base 2 is 3c plus 1. And now again, they're asking us to find the area of that trapezoid. So area of a trapezoid is 1/2 height times the sum of the bases. So it's going to be getting all of our values again. I know what base 1 is, I know what base 2 is, and the height, instead of 4, the height this time is some unit c. We don't know exactly what that length is. All right, plugging everything in, we have 1/2 c times sum of the bases, 1 plus 3c plus 1. So I get 1/2 c times 3c plus 2. And let's distribute the c. In fact, let's distribute the 1/2 c. So this is going to be 1/2 c times 3c is 3/2 c squared. 1/2 c times 2 is going to be just c. Half of 2 is 1, and c times 1 is c. So the area is 3/2 c squared plus c, and I believe we're still in feet. Okay, well, what does this mean? Part C, what does the area under the curve represent? Again, this represents distance. So the area under this trapezoid for some value c, again, represents the distance traveled. All right, I hope this clarifies number 10. If not, make sure to Zoom with us. You've got 3 days of review, essentially. Well, 2.5 if you want to count the first day as a half. Have a great day, people.